Welcome to CARB's tester training for California's Heavy Duty Inspection and Maintenance Program. We refer to this as the HDI&M program for short. This module will cover the requirements regarding submission of vehicles onboard diagnostics, or OBD data, in the HDI&M regulation. The information presented in this module is not all-inclusive and does not replace or supersede any of the HDI&M regulation. Your objectives for this module are to learn some general information about the OBD system in vehicles that monitor for emissions-related issues and how these OBD systems are utilized as a vehicle compliance test within the HDI&M program. Some of the most important information covered in this module are: what is the OBD system in a vehicle? What are the components of the OBD system? Why is the OBD system needed in a vehicle? What are the benefits of OBD testing over traditional smoke opacity tests? What entities and vehicles are subject to the OBD data submission requirement in the HDI&M program? What are the CARB-required OBD data in the HDI&M program? And how to perform and submit an OBD test as part of the HDI&M program. The HDI&M program requires all non-gasoline vehicles with a gross vehicle weight rating, or GVWR, greater than 14,000 pounds to pass emissions compliance tests to operate in California. An OBD test is the required compliance inspection method for two groups of vehicles equipped with an OBD system. Group 1, 2013 model year and newer diesel engines and diesel hybrid systems with 2013 model year and newer engines, and Group 2, 2018 model year and newer alternative fuel engines and alternative fuel hybrid systems with 2018 model year and newer engines. Only HDI&M testers are permitted to do OBD testing and submit the testing results to CARB. HDI&M testers are individuals who have successfully completed the full HDI&M tester training package and have obtained the proper testing equipment to complete the inspection. Further details related to HDI&M program requirements, such as program start dates, the frequency of OBD testing requirements, and other regulatory requirements, can be found in the regulatory module in this HDI&M tester training package. So, what is an OBD system? The OBD system is a standardized system in vehicles whose main function is to monitor the performance of the vehicle's engine and emissions-related components and detect malfunctions in them. Upon detecting an emissions-related malfunction in the vehicle, the OBD system illuminates a malfunction indicator light, or MIL, to notify the vehicle operator of the detected malfunction. The OBD system also stores information about the detected emissions-related malfunctions. This information is useful to technicians to properly diagnose and repair the malfunctioning components. It is important to understand that the vehicle's OBD system only monitors emissions-related components and systems. Therefore, the data recorded by the OBD system is strictly related to the performance and status of the vehicle's emission control components. Examples of vehicle emission control components are selective catalytic converter, or SCR, diesel particulate filter, or DPF, and exhaust gas recirculation, or EGR system. Any malfunction in these emission control components could result in increased vehicle emissions. The OBD system does not monitor parameters unrelated to emissions. For example, the OBD system won't tell you if there's a flat tire or a problem with safety features like brakes or the airbag. As mentioned earlier in this training, the OBD system plays a critical role in minimizing vehicle emissions by ensuring that all the emission control components are functioning properly and identifying emissions-related problems as they occur. The OBD system in the vehicle provides for an effective and relatively inexpensive emissions inspection, and the information it provides also helps technicians to properly diagnose and repair emissions-related problems. Moreover, the monitoring of these emissions control systems encourages engine and parts manufacturers to design more durable equipment. Compared to the traditional smoke opacity testing that has been used as heavy-duty vehicle compliance tests as far back as the 1990s, the OBD system provides more comprehensive information about the vehicle's emissions control system, enabling enhanced detection of emissions-related issues. For example, the OBD system monitors all emissions-related components, including those that impact both oxides of nitrogen and particulate matter emissions, whereas the smoke opacity tests only relate to particulate matter emissions. Another advantage of the OBD system to smoke opacity tests is the convenience of performing an OBD test and submitting the results. Compared to a smoke opacity test, an OBD test typically takes less time to perform and requires less expensive testing equipment. The OBD test also benefits from a streamlined process for submitting the results. Any OBD system includes two main component categories, hardware and software. Hardware is referred to the physical components of the OBD system that include, but are not limited to, sensors and actuators that monitor emissions-related engine components, the malfunction indicator light or MIL that is a visual notification on a vehicle's instrument panel and notifies the driver of an emissions-related malfunction, and the Data Link Connector or DLC, which is a diagnostic connector port on the vehicle used to read OBD data from a vehicle. The top picture on the right is an illuminated MIL on the vehicle's instrument panel. The bottom picture is a Type 2 9-pin data link connector, which we'll discuss in more detail later in this module. The other main component is software. Software is the computer code programmed into the OBD system that controls its monitoring and diagnosis functionalities. The OBD system software is calibrated to specific thresholds when detecting emissions-related issues. For example, the system is designed to trigger a MIL when it detects any failure or deterioration of the cold start emissions reduction control strategy that leads to emissions greater than 1.5 times a vehicle's emissions certified standard. OBD systems in light and heavy-duty vehicles are standardized to ensure OBD systems developed by different manufacturers function similarly. These standards are developed by the Society of Automotive Engineers, or SAE, and the International Organization for Standardization, or ISO, and the manufacturers are required to meet them. In the U.S., all vehicle OBD systems are certified to meet CARB and U.S. EPA regulatory standards prior to sale. OBD systems have built-in verification processes to ensure accuracy in detecting emissions-related faults. Specifically, in order for the OBD system to illuminate the MIL, an emissions fault must be detected in 2 successive drive cycles of the vehicle. This requirement ensures an emissions-related issue is present prior to illuminating the issue to the operator and minimizes the potential for errors. Further, the OBD system has a self-healing functionality, whereby if an emissions-related issue is no longer detected by the system, the MIL will turn off, letting the operator know that the issue is no longer present. The MIL, as shown here, is a standardized amber-colored engine symbol on the vehicle's dashboard. The OBD system is required to illuminate the MIL to alert the vehicle driver when the system detects an emissions-related malfunction. Operating with the illuminated MIL often results in increased vehicle emissions and can result in a noticeable impact on fuel economy and engine performance. When a MIL is illuminated, the vehicle should be repaired as soon as possible to avoid permanent damage to the components. The vehicle will fail the HDI&M OBD test if it has an illuminated MIL. Therefore, it should be repaired before completing the OBD test. To perform the HD-I&M vehicle compliance test, the test device needs to be plugged into the vehicle's Diagnostic Link Connector, or DLC. The DLC is a standardized connector used to plug into OBD scan tools to access the vehicle's OBD data. Depending on the vehicle's make and model year, the DLC can have different shapes and colors. In vehicles using the SAE J1939 communication protocol in their OBD system, the round DLC with the 9-pin connector is used. In vehicles using the SAE J1979 communication protocol in their OBD system, the rectangular-shaped DLC with the 16-pin connector is used. Here you can see all the different types of DLCs used in heavy-duty trucks. The top two DLCs are found in trucks using the SAE J1939 communication protocol in their OBD systems. The black round connector is known as the SAE J1939 Type 1 DLC. It is used in trucks equipped with pre-2016 model year engines. It has a communication rate or baud rate of 250 kilobytes per second. The green round connector is known as the SAE J1939 Type 2 DLC. It is used in trucks with 2016 and newer model year engines and supports a baud rate of 500 kilobytes per second, double the baud rate of the Type 1 DLC. The bottom DLC in the picture is known as the OBD2 Type B or 16-pin connector. It is found in trucks using the SAE J1979 communication protocol in their OBD systems. It supports a baud rate of 500 kilobytes per second. The DLC may be located in a variety of areas in the vehicle cabin. The DLC is typically located inside the vehicle cabin in the driver's side footwell region below the steering wheel. The red asterisks in the top photo represent areas where the DLC may be located in the driver's side footwell region. Occasionally, the DLC is located in the overhead region in the vehicle cab above the driver, such as in transit buses. The red arrow in the bottom picture represents where the DLC may be located in an overhead region. In some trucks, telematics or other tracking devices may be plugged into the DLC. These devices would need to be temporarily removed in order to perform the HD-I&M OBD test. This table shows the types of DLCs found in heavy-duty vehicles of different makes and model years. Please note that this is a general list, and you will need to check the vehicle's manual to confirm the type of connector installed on the vehicle. The HD-I&M test is performed by plugging a CARB-compliant OBD testing device into the vehicle's DLC to collect the required data and transmit it to CARB. OBD data collected during the compliance test includes parameters to validate proper operation of the vehicle's emission control components and ensure the OBD test was performed correctly. The table on this slide shows a summary of the required OBD data for the HD-I&M program. We will introduce some of the key OBD parameters to be collected as part of the HD-I&M OBD test in more detail here. Mill status data. This parameter reports whether the mill is off or on at the time of performing the OBD test. Diagnostic trouble codes, or DTCs, also known as fault codes, are also collected as part of the inspection. The collected data reports whether or not the three different types of DTCs, active, pending, or permanent, were present at the time of the testing. The mill is illuminated when active DTCs are present and designate an emissions-related issue. Permanent DTCs consist of active DTCs that can only be removed by the OBD system itself. Permanent DTCs consist of active DTCs that can only be removed by the OBD system itself. These codes cannot be cleared by a diagnostic scan tool. Hence, the OBD system itself has to self-heal to remove these DTCs by completing the necessary drive cycles without the emissions-related issue present in the vehicle. Pending DTCs are potential faults that have not completed the necessary confirmative drive cycles to constitute a potential emissions-related issue as an active fault. Pending DTCs do not impact a pass or fail determination in regard to the OBD compliance test, but provide helpful vehicle information of potential future issues. Additionally, information useful for identifying the vehicle being tested is collected as part of the inspection. This includes information such as the VIN, engine serial number, and OBD systems calibration information. This information is critical for validating the performed test. Another key parameter in the OBD data is the readiness status of the OBD monitors. This information helps determine whether the necessary vehicle operating drive cycles have been completed in order to allow the OBD system to run and check for emissions-related faults. If the needed drive cycles have not been completed, the OBD system has not yet necessarily had enough time to fully determine whether the emission control components are operating as required or not. Other parameters, such as distance traveled since last DTCs cleared, number of warm-ups since last mill on, are also collected as they reveal important information about the tested vehicle's operation. It is considered bad practice to clear diagnostic trouble codes or DTCs shortly before performing the Clean Truck Check emissions test. Clearing DTCs will also reset readiness monitors within the OBD system. To properly assess the vehicle's emission systems and determine vehicle compliance with the Clean Truck Check, certain readiness monitor checks will need to be completed. These checks are self-performed by the OBD system, and the criteria for completing and validating certain readiness monitors varies. As a general rule, clearing DTCs with a diagnostic scan tool or by disconnecting the vehicle's battery shortly before performing an emissions test can result in a rejected test and delays in obtaining emissions compliance. If a rejected test is the result of recently cleared DTCs, an additional test will need to be performed after the readiness monitor tests have been completed. Here, you can see an HD-INM OBD testing device set up in a vehicle for testing. The OBD testing device can consist of two components: a physical interface that connects to the vehicle's DLC, the green port shown in this photo, and a computer with the testing software installed. To perform the OBD compliance test, you must ensure that you have the proper testing device interface adapter, i.e. the cable that attaches into the DLC. OBD testing devices used to complete the OBD compliance test may vary, but in general will likely operate similar to the one shown here in this photo. Refer to the owner's manual of your testing device for specific installation and operating instructions. Not all OBD testing devices will require an HD-INM tester to perform a compliance test. For example, all data collection and processing for a CARB-compliant telematics testing device are handled directly by the device vendor, without the need for anyone such as an HD-INM tester to do anything. However, as these telematics-based testing devices are not run by HD-INM testers, they are not included as part of this training. Note that all current OBD testing devices used to perform the OBD compliance test require the use of an HD-INM tester to perform the inspection. A list of devices that meet CARB's OBD data format submission requirements can be found on CARB's HD-INM website as shown here. This list will be continuously updated as new devices become available. We are now going to briefly describe the process to complete an HD-INM OBD compliance test. Again, please note that there may be multiple testing devices available. However, this process will generally be the same for each device. Before beginning the test, you need to make sure that the vehicle is parked and the engine is running at idle. You must ensure you have a stable internet or Wi-Fi connection and that the computer used for testing is connected to the internet. And furthermore, any software required to complete the testing, which you will get from your device vendor, needs to be installed on the computer you are using to perform the compliance tests. You must also establish an account with login information through your device vendor. As shown in these pictures, connect one end of the testing interface to the computer's USB port and the other end to the vehicle's DLC. Ensure that the testing device is connected directly to the vehicle's DLC, which is the standardized OBD port, typically to the left and below the steering column. Any other devices or splitter cables should be removed prior to testing. Pay attention to the type of DLC as explained earlier in this training. On your computer, click User Information to enter your user information, which will include your CARB-issued HD-I&M Tester ID. The next slide will show you an example screen for entering user information. A user information menu will appear on the screen, similar to what's shown here. Now enter information about yourself as the HD-I&M tester, including your name, the HD-I&M Tester ID that CARB will issue to you when you pass this training series, your email address, and password. Your email and password must be the same as you used when you established the vendor account we mentioned previously. Next, click on the Login to verify the email and password combination is correct. It is essential that only valid and correct information is entered in the screen to avoid invalidating the data submitted to CARB. Next, click OK to complete this menu. Next, click the Interface settings to enter information about the interface device that will be used to record the OBD data. On the next slide, we'll show you an example screen with the interface and device communications protocol options to select from the pull-down menus. You will now use the pull-down menus to select the applicable SAE communication protocol for the engine, either the SAE J1939 or SAE J1979 protocol. Enter the correct baud rate, either 250 or 500 kilobytes per second. And finally, select the name of the interface device you are using to connect to the vehicle. Click OK when done. Note that selecting the correct communication protocol and baud rate is an important step in performing the Clean Truck Check emissions test. Confirming and selecting the appropriate protocol and baud rate will avoid communication errors, which could lead to issues and delays in obtaining vehicle compliance. The test will be performed in one of three protocol and baud rate combinations. These are J1939 at 250 kilobytes per second, J1939 at 500 kilobytes per second, or J1979 at 500 kilobytes per second. Note that the J1979 communication protocol only uses a 500 kilobytes per second baud rate, while the J1939 can use either 250 kilobytes per second or 500 kilobytes per second. To determine the appropriate communication protocol and baud rate, note the physical characteristics of the OBD Data Link Connector or DLC, typically located in the driver's side footwell. The J1979 DLC will be a 16-pin connector shaped like a trapezoid. The J1939 DLC will be a round 9-pin connector that is either black for a 250 kilobytes per second baud rate or green for a 500 kilobytes per second baud rate. When this menu appears, click Upload Results. After you select Upload Results, another screen will appear to prompt you to enter vehicle information before the test can begin. From this menu, enter the vehicle identification number and license plate number in the corresponding fields. This is required information to successfully complete the test. You may also enter additional information that may be relevant in the comments section. Next, Click OK, and the interface device will now connect to the vehicle and record all required OBD data. This process may take a few minutes to complete. Do not disconnect the interface device or turn off the engine during this process. The Vehicle Information Number, or VIN, must manually be entered by the tester before performing a Clean Truck Check emissions test. VIN errors may result in delays in obtaining vehicle compliance. Therefore, checking the accuracy of the VIN is an important step when performing Clean Truck Check emissions tests. The most common mistakes are missing or incorrect characters. For example, entering the number 0 versus the letters O or D, the number 8 versus the letter B, or the number 1 versus the letter L. It is important to note that standard VINs are 17 characters in length and contain both numbers and letters. However, VINs will never contain the letters L, O, or Q. The VIN can typically be found on the vehicle's driver's side door or door jamb, or on top of the driver's side dashboard near the windshield. Once the OBD data has been recorded, a new screen message will appear to indicate the OBD snapshot has been completed successfully. This notification will also request you to upload the data to CARB. Select Yes as shown. Make sure the connection to the internet is not disrupted at this stage, as it is needed to upload the test data record to CARB. Following successful transmission of the test submission to CARB, you will receive a final notification similar to what you see in this picture, informing you that the OBD test and upload was successful. Click OK, and you can now close the testing program and disconnect the device from the vehicle. Congratulations, the OBD test is now complete. After submitting the results to CARB, you will receive an automated message at the email address you entered to start the test that informs you whether the vehicle passed or failed the OBD compliance test. A passing test is needed to meet the HT-I&M regulatory requirements. On the next slide, we'll go over some of the reasons a vehicle will fail the OBD compliance test. A passing OBD test submission should be free of indicators of emissions-related issues. Examples of emission-related issues, including other conditions that may cause a vehicle to fail the OBD compliance test, include an illuminated malfunction indicator light and/or diagnostic trouble codes, which we discussed earlier in the presentation. The OBD system's readiness monitors indicate the vehicle hasn't been driven enough to ensure sufficient time for the OBD system to check for emissions-related issues. The compliance test is performed using an OBD test device that doesn't meet CARB's requirements. Only test devices that are shown on CARB's OBD test device webpage can be used for compliance testing, and the submitted OBD data doesn't match data that would be expected for a particular vehicle make and model. It is considered bad practice to clear diagnostic trouble codes, or DTCs, shortly before performing the Clean Truck Check emissions test. Clearing DTCs will also reset readiness monitors within the OBD system. To properly assess the vehicle's emissions systems and determine vehicle compliance with Clean Truck Check, certain readiness monitor checks will need to be completed. These checks are self-performed by the OBD system, and the criteria for completing and validating certain readiness monitors varies. As a general rule, clearing DTCs with a diagnostic scan tool or by disconnecting the vehicle's batteries shortly before performing an emissions test can result in a rejected test and delays in obtaining emissions compliance. If a rejected test is a result of recently cleared DTCs, an additional test will need to be performed after the readiness monitor tests have completed. In conclusion, testers should not clear diagnostic trouble codes and should be aware that performing the Clean Truck Check emissions test shortly after DTCs have been cleared is not advised. As we have now reached the end of this training, let's summarize what you have learned about in this course. You have learned about what the OBD system is and its purpose. You have learned what a mill is and its significance. You have learned the different types of DLCs that may be present in heavy-duty vehicles. as well as the data that is collected during HT-I&M OBD compliance tests. And finally, you have learned how to perform an HT-I&M OBD compliance test and submit the results to CARB.